Heapsort. The heap data structure. A heap is a nearly complete binary tree with following two property. First one is structure property, then another one is heap order property. Structure property means all the levels are filled except the last one. And the heap must be filled from left to right. Next, heap order property. Heap order property, there are two types of heaps are there, minimum heap and maximum heap. In the maximum heap, the root is the maximum element of the heap. The minimum heap, the root is the minimum element of the heap. Array representation of heap. This is a maxed heap shown here. The root contains 16. 16 is the maximum element. Store like this: 16, left child, right child. Then left child of 14, right child of 14. Then left child of 10, right child of 10. Like this we have to store in the array. Root of the tree is in a of 1, left child a of I equal to a of 2i. Right child of a of a equal to a of 2i plus 1th location. For example, root a of 1, then a of I equal to left child 14 is in position 2. Right child is in position 2i plus 1. 2 plus 1, 3. 4 is in fourth value 8. Fourth value 8, parent 14, 2. So left value 2 into 2, 4. Right child 2 into 2 plus 1. So operations on heaps. To maintain a heap, max heap property, the max heapify operation is there. Then to create a maximum heap, build max heap. To sort, heap sort of. Then heap types. Max heap, the root node always having maximum element than the child element. In the min heap, the root value always smaller than the child value. Heap property, it should be filled from left to right. To eliminate the violation, exchange with the largest child, move down the tree, continue until not smaller than the children. For example, 14 and 7, maximum 14, root is 4. 4 is less than 14, so move 14 up. The max heapify procedure is the left of I is I, right of I is stored in R. If L less than N and A of L greater than A of I, then largest is L, otherwise largest is I. If R less than or equal to N and A of R is greater than the largest, then largest equal to R. If largest not equal to I, then we have to exchange. After that, again we have to heapify. Next, building a heap. In the build heap, we convert an array into max heap. For build heap, first let n equal to length of the array. For I n by 2 to 1, how to do max heapify a of I comma n. Heapify we already see, compare left child and right child. check which one is maximum, then compare with the root. If root is less than that element, how to move the maximum element to the root. So heapify procedure. And here also we are calling the heapify procedure. Example. For 16 and 7, 16 is the maximum, so no change. Next, this I equal to 4, 14, 8, 14 maximum. So we have compared with the root 2, so 2 is lesser than 14, so move. Then check here. Here 9 and 10, 10 is maximum, 3 is less than 10, so move 10 up. Then 14 and 16, 14 and 16, 16 is maximum, compare with 1, 16 is maximum, so you have to move. So 1 is here, again 7 is, 1 is here, 7 is greater than 1, so move 7 up. Then check 10 and 16, 16 is maximum, compare with 4, so move 16 here. 4 is here, again 14 is maximum, you have to move down 4 here. Then 8 is maximum, so move down the 4 in this position. Heap sort. Sort an array using heap representation. First we have to build a max heap. Swap the root with the last element. Second step, swap the root element with the last element in the array. Next, discard the last node by decreasing the heap size. Then call the heapify procedure for the new root. Repeat this process until one node remains. The procedure is, in the first step you have to build a max heap. Then first we have to build a max heap, then swap the root element with the last element. After that, discard the last node. Then for the remaining elements in the heap, how to do heapify. Since the root is changed, how to do again heapify procedure. Repeat the process until the heap contains one node. Example, we are building the heap. Swap 7 and 2, discard the node 7. Then for the new root 4, how to call heapify procedure. Heapify procedure, the root node always contain maximum value. So next, exchange the root with last node, discard the node. Then for the new root, apply heapify. Again it is already in the correct form. Then exchange 3 and 1, discard the node and apply heapify procedure. Then exchange 2 and 1, remove that node. Now the heap contains only one node. So stop the process. So the started element is 1, 2, 3, 4, 7. Procedure Heapsort. Build max heap of, then for I equal to length a down to 2, exchange a of 1 and a of I, root element with the last element. Apply the heapify procedure. The running time is order of n log n. Shown here, order of n, order of log, order of n, order of log n, n minus 1 times this procedure is executed. Using priority queues, each element is associated with the value priority 12, 9, 4. Insert of s comma x used to insert element into the queue. Extract of max of s, remove the largest key value. Maximum of s returns the element which is largest. Increase key, it is used to increase the value of element to k. K is the value which is greater than the x. Increase. Heap maximum, return a of 1. Always the root contains the maximum element in the max heap. So returning a of 1 returns maximum of the array. Heap extract, it is used to extract the maximum value. The root is the largest element. After extracting, how to decrease the heap size by 1 and how to call heapify. Extract max, maximum 16. 16 is removed, then decrease the heap size by 1. So 1 is moved to in that position. Now apply heapify procedure. 14 is greater than 1. So move 14. Then 8, 7, 8 is maximum. So move 1 down. Next 2 and 4. 4 is maximum. So move 4 above. Using priority queues, each element is associated with the value priority 12, 9, 4. Then increase key used to increment the value, increment a value to a new value. Example.